Welcome to qnawire.
This question asks us to figure out how many different isomers we could get by replacing one hydrogen on each of these compounds with a chlorine. So what we're going to do is draw out each compound and then figure out how many different types of hydrogens there are, because for every unique type of hydrogen, that is a unique isomer that we could create by replacing one with a chlorine. So starting with letter A, N-pentane. N just means straight chain. So N-pentane looks like this. So these two carbons on the end here, these are both CH3s. These are identical. So only one of them is going to count as a unique spot to put a chlorine. So there's one possibility right there. Same thing with the next carbons in. This methylene group and this methylene group are the same. So they are another possibility. I don't know what just happened there. They are another possibility. And then this one in the middle is also unique. So there are three possibilities for part A. Part B is 2-methylbutane. So if we draw that out, that looks like this. Number 2 has the methyl group on it. So here, these two methyl groups are actually the same because they are on the same carbon and they're both methyls. So these represent one possibility. The carbon they're attached to is another possibility. And then we only have one CH2 group in this whole molecule, so that is unique. And then also the methyl group on the end is unique. So there's a total of 4 options for part B. Part C is 2,4-dimethylpentane. So if we draw that out, that looks like this. So 2 has a methyl group and 4 has a methyl group. So here we have a similar situation to as we had in part B. These two methyl groups are the same, and they're actually also the same as these two. All 4 of these methyl groups are identical because this molecule has some symmetry right down the middle there. That's a 2. These represent one possibility altogether. The carbon that they are connected to, also, both of these are the same, so that's another one possibility, and then the one in the middle is unique. So there's 3 options for part C. And then part D is methyl cyclobutane. So that looks like this. It's a methyl group coming off of one corner. So here, obviously this methyl group is unique, so that is one possibility. The one it's connected to is unique, so that's one possibility. And then these next 2 carbons on either side are identical, so they are together only one option. And then also the one at the opposite corner of the methyl group is considered a unique spot. So there's also a total of 4 for part D.